Okay, good afternoon to all.
Good afternoon, madam.
Okay. Welcome all the students for the last session of database management system, DBMS, that means database management system and implementation. So in last month, we were discussed about some SQL parts, and before that, before your examination, that means first semester examination, we were discussed about database. So this is just a revision session. If you have any questions or any doubt, feel free to ask from me. So in this session, I'm going to discuss about some key points from your syllabus, key points from your syllabus. Um, Okay, first of all, let's discuss about database. I think now you have clear idea about database and their operation and also SQL. Let's discuss about some key points. So under this revision session, first of all, let's discuss about introducing the database. In this case, you need to have some idea about what is the data and what is the information, what is the difference between data and the information. So okay, so what is this data? When we consider about data, we call raw fact as data. So the data are raw facts. When consider about raw facts, you can say it raw fact is used to indicate that the facts have not yet been processed to reveal their meaning. As an example, let's take a shop. When we consider about a shop, you can see when transaction take place, it will automatically generate the invoice. As an example, let's take a shop, and this shop for a salesperson going to generate an invoice when the transaction take place. Okay, in this invoice, you can see invoice date and the name of the salesperson and the time, and you can see quantity. This is the product, and then the quantity and the price. Okay, when we consider about these details, that means the quantity and the price and the sale amount. So these are separately we can consider as a data. Okay, so these are data. Then let's see what is this information. Information is known as, that means process data is known as information. So you can convert information data to the information by processing data. So you can see I already discussed about invoice case. So now I'm going at the end of this, at the end of the month, as example, let's take January. At the end of the month, this shop is going to find their business sales and or the profit that they earn during the January month. So to calculate profit, we need to process this data. So you can see when we consider about one day, you can see there are so many transactions took place within a day. So you can see there are so many invoices. We can collect all these invoices from January 1st to January 31st. Then we can process this invoice, and after that we can create or we can find the monthly sales as well as the profit of the January month. So you can see by using this data separate invoice, we can take all these separate invoice and we can produce monthly sales and profit. So when we consider about this one invoice, it can consider as a data. Information within the invoice can be considered as a data, and after we find in the monthly sales and the profit, we can set these two units as information. Okay, so this is the main difference between data and the information. Okay, I think it was clear. Do you have any questions about data and the information? Data means data are raw facts and the information is processed data. So the processed data is known as information. You can see the relationship. Data can be converted into information by processing data. So this is the basic concept. Okay. Then let's move into data management. I think now you have some idea about what is data. Let's discuss about data management. When consider about data management, it is a discipline. That means it's a subject that focus on the proper generation, storage and retrieval of data. When we consider about data management, there are three basic component or parts in this data management scenario. The first one is proper generation. That means generation of data. You need to generate data. Then the second component is you need to store the data. So you need to provide proper storage for the data. Then you can retrieve this stored data for various purposes. In our previous case, you can insert invoice data into a file. As example, let's take a file. So you can include this invoice into a file like this. After that, at the end of the month, you can retrieve this invoice and you can find or you can produce the monthly sale report. Okay, so you can see when consider about data management, there are three basic scenarios. The first one is you need to generate proper data, then you need to store that data, and also you need to retrieve this data for various operations. So this is known as data management. Okay, then the next one is database. Okay, when we consider about database, this is about data and the data management. Then let's discuss about database. You can see database is a collection of related data. You can see database is a storage media. So you can, in our previous scenario, you can see generate data, store data and retrieve data. So the database is a storage media. So the database is a storage media which is used to store the data. When we consider about this database, it's a collection of related data. Okay, as an example, I'm going to erase this one. Okay. You can see when consider about database, as example, let's take your student information database. Student information database. So you can see in this database, it's only consists with student information. Okay, student information, student name, then the age, and also some other data about students. So when we consider about student information system as a separate database, you can see it only consists with student details. Can this database have data about the politicians? When we consider about student information system, can we find politician data in this database? Is it possible?
No.
Yeah, it is impossible to have politician data within this student. Yeah, no, student information database. So when we consider about database, always database is a collection of related data. So this is very important, related data. Okay. Okay, so this is about database. Then let's discuss about what is this metadata. When we consider about metadata, it's a it provides a description of data characteristics and the set of relationship that link the data found within the database. This metadata, you can, I think you have some idea about SQL. When we consider about SQL, you can see there are three main SQL components. The first one is DDL, then the DCL, and the DML, data definition language, data control language, and the data manipulation language. When we consider about this DDL, that means data definition language, you can say it is used to, this language is used to define the database. In this scenario, it always cover this metadata. So you can see metadata always provide the description of the data characteristics. As an example, let's take a student. When we consider about student table, okay, student table can be consist with the student name, then the student ID. When we consider about this student name, this is data. So you can see when consider about a student name, this attribute has a data type. When we take as a student name as a separate attribute, you can see this attribute has a data type as well as field size. So these are the characteristics of this data. Okay, so this metadata always provide the description of the characteristics and the set of links. That means data of relationship that link the data found within the database. So this is known as metadata. Then let's discuss about database management system. Up to now, we discuss about data, then the information and the data management, and also what is the database and what is the metadata. Now we are going to discuss about database management system. So you can see database management system is a collection of programs that enables user to create and maintain a database. So database is a component. So this is a program or a collection of program which is used to create and maintain a database. So database management system is consist with DBMS and database. Okay. So the database management system is a collection of programs that enables user to create and maintain database. And there is another definition for this DBMS, short form is DBMS. So it is a collection of programs that manage the data structure and the control of the access to the data stored in the database. You can see we can use is a collection of programs that manage the data structure. We can define data structure by using DDL, and you can control access to the data by using DCL, data control language, mainly grant and revoke. Okay, these are the main two SQL command used to control the access to the data stored within the database. Okay, so this is the simply database management system is a collection of program which is able to or which provides user to create and maintain a database. Okay, so okay. When we consider about this database management system, this DBMS facilitate with three functions. The first one is defining a database. The second one is constructing a database and the manipulating the database. So DBMS always facilitate with three functions: defining a database and the constructing a database and the manipulating a database. There are three stages: defining, then constructing database and the manipulating database. In SQL, we use DC, that means DDL, data definition language, to define the database. And constructing also we use DDL, data manipulation language, to manipulate the database. So first, let's see what is this defining the database. What is meant by this defining a database? Okay. So in this case, you can specify the data types and the structure and the constraint for the data to be stored within this database. As an example, you can see, let's take a OUSL database. Under this defining a database function, you can define what are the tables available in this database. As an example, let's define some tables as course, then the student, then the lecturers, then the grade, that means result. Likewise, you can define different type of data structure within this database. Okay, then you can construct. So this is about defining a database now. Then the constructing a database means processes storing the data on some storage media. So you can, first you can map, this is the database, these are the tables, and these are the fields or attributes available in this table, and this is the field size, and this is the field type. Likewise, you can map your database. After that, you can construct your database. To construct your database, it is needed to maintain a storage medium to store the database and their data. So this function is facilitated by DBMS or a database management system. Okay, after that you can manipulate data. We already mapped the database and we create the database and we store this database within the database management system. Now we are going to manipulate this data. Manipulate means we can perform different type of task on the data. That means different type of operation within the operation on the data. So you can see after store this data into a student table, we can retrieve this data. So this database management system facilitating to facilitate or it's provide query to retrieve the specific data from the database and the table, and also it facilitate update facility. You can update the data, you can insert data, as well as you can generate different type of reports by using this data. So that manipulating database means you can perform any different task on the data stored in storage medium. So DBMS mainly provide three functions as defining a database, constructing a database, as well as manipulating a database. This is about database management system. Okay, I think now you have some clear idea about key points from our previous lectures. Okay, then let's discuss about database system. What is this database? So the database system. Database, I already told that database system is a collection of DBMS, database management system, and the database. Okay, so this database management system provides three functions: defining a database, constructing a database, and manipulating the database. This DBMS plus database is together known as a database system. So this is a database system. Okay, as an example, let's just take MariaDB service. So you are going to create OUSL database within this MariaDB server, database management system. So all this OUSL and the Maria server together called as the database system. Okay, then let's discuss about what is database designing. Database designing is a designing of the database structure that will be used to store and then manage the data rather than designing the DBMS software. This is about designing a database. Okay, then let's discuss about very important topic. It is about redundant data. So what is this redundant data? Can someone try this? What is meant by redundant data?
Duplicated data.
Yeah, definitely. Duplicate data is known as redundant data. Okay. Please give me 1 minute. Please rename your device with your student numbers and the name. Student numbers means S number and the name. I will give you 2 minutes. You can rename your device with student number and the name. Rename your device with your student number or a S number and the name. Altogether 81 students. Someone raise hand. Who is this? Okay. Okay, there are few students. Still not. Okay. Anyway, thank you. When we consider about redundant data, so the duplicated data is known as redundant data. As an example, let's take telephone number. In your manual file system, you are going to maintain 3 separate files as sales agent file, customer file, sales agent files, file, and an invoice file. Okay, sales agent, invoice, and the customer file. The customer is going to change his telephone number. As example, let's take a contact number. Okay, all these 3 file contain this telephone number. Okay, so cat 1 and cat 2 marks, we are going to provide your eligibility before next month, most probably at the end of this month. Okay, that means the status of the eligibility. We are going to provide your status of the eligibility for your final exam before March. So at the time you can have some idea about your CAT marks. Okay, CAT examination marks. Okay, then when we consider about these 3 files, all these 3 files contain telephone numbers. So let's take Sarath. So Sarath going to change his telephone number. At that time, you need to update these 3 files separately. So that means always you duplicate the same data in 3 places. That means you need to modify 3 places, or you need to update 3 places, 3 separate files. So that is known as duplication. So this unnecessary duplication process is known as redundant data. Unnecessary duplicated data is known as redundant data. Okay. So the redundant data can produce incorrect data entries. Yes, sometimes when you are updating separate files, so you are going to update this file as like this. But in this case, you can sometimes you may update as 071, in this case 072. So you can see at that time it can produce incorrect data. Same person's telephone number is different from this file to this file. Okay, and also this redundant data will not know which value is the correct one. Okay, after 1 month period, in this case this Sarath contact number is 07125356551. In this case, 07225356551. After 1 month, you are going to call this Sarath. You have some conflicts. In one file, the telephone number as this, and another file, this telephone number as this. You can see it's a conflict. So you do not have aware about which one is correct. So you can see this redundant data can lead or can produce in this redundant data, it will not know which value is the correct one. And also this redundant data reports might lead different results. Sometimes it can produce different type of results. Okay, so this is about redundant data. You need to have some idea about redundant data. I'm going to ask some question about redundant data, then the database management system, some theory parts in your final exam. Okay. Okay, then let's discuss about history of database. Before okay, history of database. In ancient times or before invented about computerized system, you can see manual file system is available to deal with the data scenarios. Okay, so in this case, normally we consider files and the file system. When we consider about a file, it's a collection of related records. You can see when consider about database, this database is in computerized system. Computerized system, database is also a collection of records. So when we consider about a file system, it is when we consider about a file, it's also consists with related records. So you can keep student files to record the student data, and you can keep course file to maintain course data separately. So you can see this file also consists with related records. This is also consists with records. So the definition of the file is a collection of related records. Okay. Then the file system. When we consider about a file system, it provides a useful historical perspective on the way we handle the data. By using the file system, we can have a way to handle the data. Okay, so in previous time, we use manual file system to maintain the data and the data scenarios. After that, this manual file system is converted to a computer file system. And when we consider about a computer file system, it is technically complex when comparing to manual file system. Okay, there are two types of file system: manual file system and the computerized file system. I think you have some idea about manual file system. You can see when some government, when you visit some government office, you can see at the end of, as example, you are going to meet some government officer. You can see sometimes his or her table is consist with different type of files. There are so many files in his or her table. So this files are known as a manual file system. You can maintain a manual file system. Most of the government office or a government institute, they use this manual file system. And mostly in private sector, they use computer file system to maintain their data. Okay. Okay, so these are the use of computer files. By using these computer files, this is the compare computer files with manual file system. So when we consider about a computer file, we can save much time and the effort. Okay, and also reports will be impressive, and also this computer files has ability to perform the complex data search when you need some information. Okay, as example, let's take there are 20 files in the manual file system. You can see 20 files. You are going to find some data. You need to refer all these 20 files to find the needed or a task data. Okay, but when we consider about a computer file system, you can just type and you can find the needed data. Okay, so when we consider about computer file system, we can perform a complex data operation or a data search in this computer file system. Okay, these are the main differences between manual file system and the computer file system. Okay. Up to now, do you have any questions? These are some theory parts, but I'm going to ask this theory part in your final exam. So do you have any unclear point up to now? If you have any question, you can drop a message to the chat. Okay, then there are some students. Please rename your device with your student number as well as with your name. Sadnuni Jayasinghe Sanjeevani Rukshika. Rename your device with the student number and the name. Okay, then let's discuss about again, this is about data redundancy within the file system. In previous case, we discussed about what is this data redundancy. When we consider about a file system, when we consider about a file system, let's discuss about data redundancy in the file system. You all know data redundancy is the same data stored in many different places. That means in data redundancy case, you can see duplicated data are available in different places. Okay, so you need to control this data redundancy. If you are unable to control this one, there are some issues raised due to this data redundancy. The first issue is data inconsistency. You can see if you are unable to handle the data redundancy, there are some bad issues. The first one is data inconsistency. When we consider about data inconsistency, it is a lack of data integrity. That means, let's take if you are going to maintain 3 files for 3 different, yeah, this is the last day of school before your final exam. I think your final exam will be scheduled on 12th March or I think it's on 12th March. So this is a revision session. This is the last day of school. If you have any questions about the database and the SQL, you can drop a message. Okay. When we consider about data inconsistency, you can see data inconsistency is the lack of data integrity. That means, let's see what is this data inconsistency. As an example, let's take 3 different files. I'm going to maintain telephone number of the customer in the customer file, then the agent file, and customer transaction file. So same field within 3 different location or 3 different files. So the same data in 3 different files, but we only check. Yeah, after this, I'm going to discuss some past paper questions. Don't worry. You can see now I'm going to update Sarath telephone number in this file. So I forgot to update this one. I only update these 2 files. At that time, you can see data instability can be occurred. So this scenario is known as data inconsistency. Same data can be maintained or can be in different places, but we only change 1 or 2 places. At that time, data integrity can be occur. This data integrity scenario is known as data inconsistency. Then we is this, yeah, I think it is recording. Let me check it. Yeah, it's recording. I'm going to upload this record, don't worry. Okay, then the second issue due to the data redundancy is data anomalies. Okay, in this case, there are 3 types of anomaly. 3 types of anomaly. The first one is modification anomaly, then the insertion anomaly, and the deletion anomaly. The first one is modification. In this case, you can see incorrect data may have to be changed, which could involve many records having to be changed, leading to the possibility of changes being made incorrectly. In modification, sometimes you can modify, but it may leads to being incorrect data. Sometimes you forget to update incorrect data. Sometimes you can make some mistake within update. So at that time, modification anomaly take place. And insertion anomaly, there are some scenarios inability to add some data due to the absence of other data. We already discussed about this tree anomaly in detail in our previous lectures. You can refer that video. In the insertion anomaly, you can see there are some cases. Let's take as example, primary key is student ID in the student table. So you cannot update student ID, student name. Then there is another one, course ID and the course name. You need to have a student ID in this table. So you can see there are so many records in this table, but if you need to insert a course to this course detail, it definitely need to have this student ID. There are some cases, let's take this as a department. Okay, department. This is a department number and the department name. So if you need to insert a course into this table, you need to insert department name ID. So you are unable to insert data for the course table unless you add data for the department ID. So this is make course insertion anomaly. Then the deletion anomaly. In this case, You can see unindented loss of data due to the deletion on other data. In some cases, you can see same example. Let's take same example. Department table, department ID and the department name 1, 2, 3. Then the uh, let's take like this department: chemistry, physics, and the computer science. Then there is another table as a course, course ID, course name, and the department ID. You are going to insert a course for the department number 3, that means computer science department. Course name, course ID is CS3215. Course module is data structure and algorithm. Okay, so you are going to delete this department from the department table. At that time, you can see this is already delete. That means you are going to remove this computer science department and you are going to create new one as a software engineering units. Okay, so this is already removed from the department table, but when we consider about this course table, department 3 is still available. You can see at that time there are some incorrect data within this table due to this deletion process. Okay, so this kind of things are known as deletion anomaly. Okay, anomaly. Okay, someone wait. Okay, so this is about data redundancy and their issues. Okay, then let's discuss about database management system. I already told that database system is a database management system. Sorry, DBMS plus database. These two components together is known as database system. This is an organization of components that define and regulate the collection, storage, management, and the use of data within the database environment. So this is known as a database system. Database system is an organization of the components that define and regulate the collection, storage, management, and the use of data within the database environment. Okay. You can use this one, and you can use this database or database system, DBMS. You can use one of definition. There are 2 or 3, I think 2 definition. You can choose any. Okay. Okay, then this is about database system. So, okay, when we consider about this database system, I already discussed about DBMS plus database is known as a database system. When we consider about a database system, this database system is composed with 5 major parts. When we consider about database system, this database system is composed with 5 major parts. The first one is hardware, software, people, procedure, and the data. You need to have some idea about these these 5 major parts. You need to have some idea about what are the software, what is meant by software, what are the software used in database system, and what is this hardware, what is the procedures, what is the data. Likewise, you need to have some idea about major parts of the database system. Okay. Okay. Then let's discuss about classification of database or a types of database. So when we consider about the types of database, you can classify this database by using the number of users and the database site location and the expected value and the extent of use. Okay, extent of use. These are the main three classification scenarios of the database. You can classify database by using the number of users and also the database site location and also expected type and the usage of the database. Okay, when we consider about the first case, number of users, you can divide your database management system into two parts as a single user database management system or a single user database and the multi-users database. In this single user scenario, this DBMS support only one user at a given time. In multi-user case, it support multiple user at the same time. So this is the main difference between single user and the multi-user database. In single user database, it's only have an ability to use that means it's only support one user at a particular time. In multi-user case, this DBMS support many users, one user, two user, or a 3, 4, 5, any number of user in the same time. Okay, so this is the classification of database based on number of users. Then we are going to discuss about the classification of database based on database site location. Okay, you can see the location. We can classify our database based on the location. We can classify database into two as centralized DBMS and the distributed DBMS. In this case, in centralized case, you can see one centralized database available in a server. Okay, you can see this is the OUSL database. This is only in one central point. Okay, many users can access this database, but this is located in a single site or a single place. So this is known as a centralized DBMS. We can many customer can use or many users can use centralized database in the same time, but it's only located at a single site. So this is known as a centralized database. When we consider about distributed DBMS, you can see it support database distribute across several different site location, and it is called a distributed DBMS. As an example, let's take a Google. Google going to maintain a Google database. You can see there are so many. This is for Google Gmail. This is for Facebook facility, and another one for what other GPS and the Google Map. Okay. Likewise, this Google organization or Google maintain different location to maintain their database. That means it support distributed across the several different site locations. So this type of DBMS, that means database management system, is known as distributed DBMS, not a central or a single site. It maintains several components in the several location, and all these several locations get together to perform some task. This is known as distributed DBMS. Then you can classify this, the third classification based on expected type. That means expected type and the extended use of the database. You can classify it into two parts, transactional DBMS and the decision support DBMS. In this transactional database, this is designed to support the immediate response transaction. As an example, you can say sales transaction within the food city or any other shop. This type of DBMS are known as transactional DBMS. In the main target of this or a main target of this DBMS is to respond immediate response for the transaction. Then the next one is decision support system. This is most probably for the top management. This type of database can be used to take some strategic decision at the middle and the higher management level. So this type of database management decision support DBMS or databases are used by the middle and the higher management. They use this DBMS to perform some strategic decision. Okay, these are the types of database. You can classify your database based on the number of location, then the site location or the location of the database, and the third one is expected type and the expected usage of the database. By using these three category, you can divide your database by using this one, single user and the multi-user. This one, centralized and the distributed. In this case, transactional and the decision support. Okay, these are the main types of database available in our society. Okay. Sorry. Okay. There are some database functions. DBMS function. You can see these are some DBMS perform different type of functions to guarantee their integrity and the consistency of the database within the guarantee of the integrity and the consistency of data within the database. So these are some functions, DBMS functions: data dictionary management, data storage management, and the data transformation and presentation, security management, multi-user across the control, backup and the recovery management, data integrity management, and the data access language and the application programming interface, database communication interface. So these are some functions performed by the DBMS. You need to have some idea about these functions. Okay. So these are the main components of the DBMS. Data standard operation, data definition language, data manipulation and the query language, programming tool and the file structures. Don't misunderstand. These are the main components in the database system. So database system is consistent with hardware, software, people, procedure, and the data. So these are the main components of database management system, DBMS. Database system, hardware, software, people, procedure, and the data. In the DBMS, data standard operation, data definition language, data manipulation and the query language, programming tool, and the file structures. Okay. Then we discussed about different data models. The first one is hierarchical data model. In this case, you can see data is organized according to the tree structure. You can see in this case, this is the root. These are the nodes in the tree. This is a real world scenario. When we consider about the employee within the company, we can create a hierarchy for these employees. Okay, as an example, let's take ABC company. We can create a hierarchy or a tier structure for the employees within the company. Altogether, all the employees we can call it as an employee. When we consider about employee, we can categorize these employees as a permanent employees, contract employees, and the intern employees. When we consider about a permanent staff, you can see this is as example. Let's take a software company. In software company, you can see permanent staff, then the contract staff and the intern staff. Okay, when we consider about this permanent staff, you can see different types of software engineers, then the database administrators, then managers, uh, business analyst, system analyst. There are so many different types of permanent staff within the database. Okay, so within the company. So you can store this data as a, or you can store this data as a hierarchy. So this is the hierarchy. First, employees. Under employee, you can see permanent contact intern employees. Under the permanent employee, you can see managers and the software engineers. So this is known as a hierarchical model of the database. Okay. This one is known as a root. When we consider about this one, this B is the parent of GHI. So this is when we compare two levels together, the upper level consists with parent, lower level consists with child. So this is when we consider about these two levels. This level is consist with parents, these two level is consist with children. Okay, so H is the child one, B is the parent of H, D is the parent of E. But there is a special case in hierarchical model when comparing to network model. Now, next we are going to discuss about network model. There is a special feature available in this hierarchical model. When we consider about one child, it only has one parent. One child has one parent. This is very important. In hierarchical data structure, one parent is having one child. Oh, sorry, one child is having one parent. So one-to-one relationships available in this hierarchical model. Okay, then let's discuss about network model. In the network model, you can see this is also just like a graph structure, and it is also this network data model is a companion or a companion of the hierarchical data model, but there is a difference in this scenario. In the network scenario, you can see one child can have many parents. So when we consider about program 1, project 1 and the project 2, so these two are the parent of this program 1. So the main difference between hierarchical model and the network model is number of parent can have. Okay, in the hierarchical model, one child can has only one parent or exactly one parent, but in network model, a child can have any number of parents. So this is the main difference between hierarchical model and the network data model. Okay, so you can see this is the graph structure. In this case, these are the records. In this case, these are known as link and the nodes. No, in network hierarchical model, but in network model, these are known as records, and this connection is known as link. Okay, so these are the main thing about network model. You can refer the lecture note about as well as record about network model. In last lectures, we will discuss about these models in detail. Okay, then the relational model. So before discuss about relational model, what is the basic structure of the relational model? What is the basic structure of relational model? Can someone answer my question? What is the basic structure of relational model?
Table.
Yeah, table. Table is the basic structure of relational model. Okay. Okay. Table is the basic structure of relational model. Okay. When we consider about this one, there are some, you need to have some idea about relational scheme also. No? Wait, okay. Okay, in relational model, you can see the basic structure is a table. You all know table is consist with columns and the rows. This is the columns and the rows. When we consider about column, normally database, in the relational database is consist with tables. In the tables, we define one table for one attribute. As example, student attribute. We are going to define a student table for student entity. In this case, you can see when consider about a student is consist with the name, then the NIC and the address, then the telephone numbers. These features are known as attributes of this student entity. When we consider about student name, it's an attribute of student entity. When you consider about the telephone number, it is also an attribute of the student entity. Okay, so you can see student entity, there are so many attributes. You can define your attributes in the column, and you can provide value for these attributes in the rows. Okay, these rows are, in relational model, rows are known as tuples and the columns are known as attributes. Okay, you can see in this is an example about project table, structure of the project table. In this case, project number, project name, date start, estimate. These are the attributes of the project. So you can see project 1 is consist with payroll. This is the project name. This is the started date. This is the estimated cost of this project. You can see this is a one record. This record is called as a one tuple. Okay, this is the data set of project 1. When we consider about project 2, this is the data set. This is another tuple. Okay. When consider about a simply table, it may consist with many tuples. Okay. You can use the primary key. In a table, you can have some idea about primary key. So what is the primary key? When we consider about a table, what is the primary key? Can someone answer my question? What is the primary key?
It's a unique key to identify one tuple.
Yeah, then the foreign key?
It is going to be a reference attribute.
Yeah, referring to another table, but there is a special feature. This foreign key should be a primary key in another table. Okay, so these are the two different key. Not there are some other keys as a super key, candidate key. There are so many keys, but these are the main two types of keys used in database: primary key and the foreign key. Okay, so primary key can be used to identify each and every records in the table uniquely. If you can use one attribute to identify each and every records in the table, this attribute can be called as the primary key. Primary key can be a composite key. What is meant by composite key?
More than one attribute function as a primary.
When one or a single attribute is contribute to create primary key, at that time it is called as a primary key. If more than one, that means more than one attributes are contribute to create a primary key, at that time that key is known as a composite key. Okay. Then the entity relationship model. Okay. We discuss about hierarchical data net model, then the network data model, then the relational data model, and the last one or the final, no, not the final one. There is another one, entity relationship model. In this case, ER diagram is the main way or a main graphical way. In DBMS, ER is very important. So this is the graphical representation of entity relationship model. When we consider about this ER model, there are mainly three components available in the ER model. The first one is entity, then the attributes, relationships. These are the main three components available in the ER model. The first one is, let's discuss about first one, it is entities. In entities, you can see we can define any place or a person or anything as the entity which the data are to be collected and stored. We can use rectangle shape to denote an entity in ER model or ER diagram. Most probably we use noun to name the entity. Okay, so course, this is the entity. When we consider about the entities, there are mainly two types of entity, as the strong entity and the weak entity. So what is the difference between these two, strong entity and the weak entity? What is the difference between a strong and the weak entity? Or what is weak entity?
It is partially or fully depend on another entity.
Yeah, if an entity is partially or fully depend on another entity, that entity is known as the weak entity. As an example, let's take employee. One insurance company is going to introduce medical scheme or insurance scheme for this company or the employees in the company. So in this employee, that means in this policy, we can have or we can register one dependent person for this medical scheme. So you can see there is a dependent. Employee can enter into this medical scheme with a dependent or without a dependent. No issue of this. So at that time, you can see dependent entities totally depend on the employees. If this employee is not in the scenario, this dependent is also not in this scenario. So the employee, this dependent entity is totally depend on this employee. So this is a weak entity. If the entity is partially or fully dependent on another entity, that kind of entities are known as weak entity. Okay. Then the attributes. The second component is attributes. Here diagram is based on entities, relation, and the attributes. No? So the attribute, then the next second one is attributes. When we consider about attributes, we can use an set of that means we already discussed about entity. Entity can be described by using a set of attributes. So the rectangle shape is used to denote the entity. You can use this oval shape to represent the attributes. So you can see attributes also have a domain. The domain of an attribute is the set of possible value of that attribute. When we consider about last name, we can have several names. This name set is known as a domain of this attribute. So this is the entity. These are three attributes of this entity. Okay. Then primary key, we already discussed about primary key. Primary key is a key which is used to identify each and every records in the entity or entity set. You can denote primary key like this. That means you can underline the attribute names. If this is the primary key, let's take this as a primary key. So you can underline the attributes to denote it as a primary key. Yeah, you can define attributes as a properties of the entities. Definitely, it's a properties of entity. Okay, then composite key. when you already discussed about composite key, this is when two or more keys, that means more than one attribute is contribute to create a primary key, at that time that that key is known as a composite key. This is a primary key. There are two keys to create a primary key. This is known as a composite key. Okay, so okay, strong and the weak entity. Normally a strong entity, when we consider about the entity, this is a strong entity. This is normally it's denoted by a rectangle. But when we consider about a weak entity, if a entity is depend on another entity, that means fully or partially depend on another entity, that kind of entities are known as the weak entity. As an example, you are going to introduce a insurance policy for a company. Okay, there are some background noises. Okay, your insurance company is going to introduce employee policy. That means a medical, as example, let's take a medical insurance policy for the employees in the company. Okay, so in this policy you can have a dependent. That means දැන් අපි දැන් ගත්තම insurance policy එකක් company එකකට අපිට තියෙනවා නේද dependent කියන්නේ මොකක්ද ඒකට කියන්නේ වචනේ සිංහල. දැන් අපිට පුළුවන් අපේ ඉන්ෂුරන්ස් එක තව කෙනෙක්ට කියන්නේ මම දැන් මැරිඩ් නම් මගේ හස්බන්ඩ් ඉන්ෂුරන්ස් එකට කන්ට්‍රිබියුට් කරන්න පුළුවන්. එහෙම නැත්නම් මගේ ෆැමිලි මෙම්බර්ස්ලා කන්ට්‍රිබියුට් කරගන්න පුළුවන් ඉන්ෂුරන්ස් එක දාන්න. හැබැයි මට තනියම මට ඉන්ෂුරන්ස් එක දාන්න පුළුවන්. We can create an insurance or we can make an insurance policy for myself myself plus family. Okay, yeah. දෙකෙන් විදිහකට කරන්න පුළුවන්. එතකොට අපි දැන් හිතමුකෝ මම ඉන්ෂුරන්ස් එක දාන්නේ මට විතරයි, ප්‍රශ්නයක් නැහැ, අවුලක් නැහැ. හැබැයි මම මායටයි මගේ හස්බන්ඩ්ටයි දෙන්නටම දානවා. එතකොට හස්බන්ඩ් කියන කෙනා ඩිපෙන්ඩන්ට් මම මත යැපෙනවා. හරිද? එතකොට හස්බන්ඩ් කියන කෙනා අපි ගන්නේ weak entity එකක් විදිහට. මම නැත්තම් ඒ ඉන්ෂුරන්ස් පොලිසි එක හස්බන්ඩ් යන්නේ නැහැ. මොකද දැන් මමනේ එම්ප්ලොයී එක කම්පැනි එකේ. ඒතර මට මේක ඉන්ට්‍රොඩියුස් කරලා දෙන්න කියන්නේ. මමනේ පොලිසි එකට බැඳෙන්නේ. ඒතර මන් නිසා ඒක ප්‍රතිලාභියෙක් වෙනවා හස්බන්ඩ්. හැබැයි හස්බන්ඩ් කියන කෙනා මම මත ඩිපෙන්ඩ් වෙලා තියෙන. කියන්නේ මම මගේ පොලිසි එක මත ඩිපෙන්ඩ් වෙලා හිටිනවා. මම ඒ කම්පැනි එකෙන් අයින් වුණොත් මගේ මෙඩිකල් ඉන්ෂුරන්ස් එක අයින් වෙනවා වගේම හස්බන්ඩ්ටත් ඒක නැති වෙනවා. ඒතකොට ඒ හස්බන්ඩ් කියන කෙනා අර මං කියන entity එක මත depend වෙලා තිනවා. අන්න ඒ වගේ dependent variable වෙලා තියෙන variable හොර entity එකක් අපි කියනවා strong entity එකක්. sorry, weak entity එකක් කියලා. If an entity is totally depend on another entity or partially depend on another entity, such kind of entities are known as dependent entity. Okay. Is it clear? If an entity is depend on another entity fully or partially, you can say that entity as the weak entity. You can use double line rectangle to represent weak entity. Okay. Is it clear, Rashmi? I think. Wait.
Yes, madam. It's clear. Thank you.
Okay. Then let's discuss about single and the composite attribute. Okay. First, let's discuss about composite attributes. When, as example, let's take an attribute. If you can subdivide this attribute into other additional attributes, such kind of attributes are known as composite attribute. You can see when consider about a name. This is an attribute. You can subdivide this name into first name, last name, and the middle name. This kind of attributes is known as a composite attribute. If an attribute can be subdivided into another attribute, such kind of attributes are known as composite attributes. Okay, this is the famous example, name. You can see your name is definitely consists with two or more components, two or more parts. So then when we consider about name attribute, you can subdivide this name attribute as the first name, last name, middle name, likewise. Okay, so the name is a composite attribute. Okay, then the simple attributes. If an attribute cannot be subdivided into further attributes, such kind of attributes are known as simple attributes. When we consider about NIC, you cannot definitely, this is the 193.75. Likewise, one number, no. So you cannot subdivide this into another entity. So definitely NIC is a simple attribute. 6. This is also a simple attribute. When we define a sex, it can be a male, female. So it's a simple attribute. You cannot subdivide this sex attribute into another attribute. So this kind of attributes are known as simple attributes. Okay. Then the single value and the multi-value. You can see sometimes there are some values for when we consider about the attribute, you can have only one value for the attribute. Such kind of attributes are known as single value attribute. As an example, NIC, definitely one person only has one NIC number. So NIC is a single value attribute. But when we consider about a multi-value attribute, you can have many values for a single entity occurrence. As an example, you can take your phone number. You definitely, most people may have two or more phone numbers. So the phone number entity is a multi-value attribute. When we consider about Kamal can have one or more telephone numbers. When we consider about the degrees, when we consider about a person, Kamal can have a degree in engineering field, then the BSc degree, then the master degree, then the MPhil, PhD. Likewise, he can have any number of degrees. So the degrees also can be taken as a multi-value attributes. Okay, this is the main difference between single value attribute and the multi-value attribute. Then there is another attribute. This is very important. This is derived attributes. Okay, this is, in this case, it is no need to physically stored within the database. Instead of this, it is derived by using an algorithm. Sometimes, mostly age is the example for this one. When you provide the date of birth to the database, in some operation you can derive your age. Such kind of attributes are known as derived attribute. You can represent derived attributes by this. No need to provide value for this one. You can derive this age by using this date of birth. So you can indicate this one by, I think, by using the dotted line. If you are Madam, do we include the derived attributes in the relationship schema? That's up to you. If you are willing to include, you can include this discount of goods. You provide this example as a discount of goods. You can include that one and you can give a comment. This discount of good is refers to this one, like this one. As example, let's take a DOB. I'm going to insert employee age into my ER diagram. Then I can give a comment at the end of this ER diagram. Employee age is derived from employee date of birth. You can provide the assumption, or under the assumption category, you can provide this one. Under assumption, you can provide assumption as employee age is derived from employee date of birth. It's up to you. If you are willing to maintain derived attribute, you can do it, okay? But it is needed to note at that one, okay? You need to note it in assumption category. Okay, then let's discuss about relationship. 3 components, entities, attributes, and the relationship. Then let's discuss about.
Ma'am, excuse me.
Okay, go ahead.
In the ER diagram, if we draw a diagram like dotted line, so it is clearly saying it's a derived attribute. So do we have to mention it in the assumption part also?
Yeah, this assumption is made by you, no? So you need to indicate it under the assumption. In as example, in your exam, it gives some scenario to draw a ER diagram, but it does not mention about this employee age. You include this one, so you need to mention it under the assumption category. Okay.
Okay, ma'am.
You are the person who include this one. That's why you need to mention it in the assumption category. Okay. Then the relationship type. So, sorry, relationship type. The relationship always describe an association between 2 or more entities. Okay. This is not a 2 entity. There are some relationship as a ternary relationship. No. So 2 or more relationship. There is another one. Unary relationship. Okay. You can see the relationship can be used to describe the association between the data. There are 3 types of relationship: one-to-one, one-to-many, many-to-many. In one-to-one case, you can see when consider about 2 entities, always this one lecturer is associated with the one course. So this kind of relationships are known as one-to-one. That means one lecturer teach only a one course, and the one course is taught by a one teacher. So this type of relationships are known as one-to-one relationship. The second category is one-to-many relationship. In this case, you can see one student can follow one subject combination. One subject combination is followed by many students. So you can see one-to-many relationships. That means let's take a lecturer and the teacher, of course. One lecturer can teach many courses. One course is taught by one lecturer. So this relationship is one-to-many relationship. This is one-to-one. Yeah, this is one-to-many relationship. Okay, you can define one-to-many. Then there is another relationship as a many-to-many relationship. In a single value, it can only have a one value. That means in a single value attribute, it is consist with one value. As an example, age. Sorry, not age. As an example, let's take sex. It is definitely female, okay, or a male. You can have one value, but in the simple attribute, it cannot be subdivided into another. That means when we take about let's take this one, name. Before that, let's discuss about many-to-many first. In many-to-many relationship, one student learn many courses and one course is learned by many students. So you can see many-to-many relationship. One student can let's take one student can learn many course. When we consider about one course, it is learned by many students. So the relationship is many-to-many. Okay, so these are the main 3 types of relationship. Okay, before moving to next part, there is a questions asked What is the difference between single value attribute and the simple attribute? Can you explain? Okay, as an example, let's take this one, name. Okay, when we consider about name, we can subdivide this name into first name and the last name. Okay, you can see this is a composite attribute. Okay, you can say this is a composite attribute. Okay, when we consider about age, okay, we cannot subdivide this into another, because when we consider about me, I'm 28. When we consider about I, that means my case, myself, my age is 28. This is constant value. Okay, so age cannot be subdivided into another one. So this is simple attribute. We cannot subdivide this age into another values. Okay, when we consider about telephone number, okay, telephone number, we cannot subdivide this telephone number into, sometimes it can be as a code and other part, but telephone number is a simple attribute. We cannot subdivide this into another entity. This is a simple. Okay, but when we consider about single, so this is the difference between simple and the composite. When we consider about single value, okay, when we consider about single value, when we consider about age, this is 28. We can have only one age. We cannot have 29, 20, 32, 35, likewise. Only one value. So this is a single value attribute. It can only have one value. But when we consider about a telephone number, it's a multi-value. You can have two telephone numbers. One age, two telephone numbers. So you can see age is a single value, but this one is a multi-value attribute. So the main difference between simple attribute and the single value is simple attributes, you cannot subdivide that attribute into another attributes. In the single value attributes, this can only have one value. Okay, is it clear? But this one, let's take this one. You have only one name, so this is a single value but composite attribute. It can be changed. Okay, this is the main difference between composites in the simple single value attribute and the multi-value attributes. Okay, then the cardinality of the relationship. So the cardinality can express the specific number of entity occurrence associated with one occurrence in the related entity. This is a one-to-many relationship. You can see in this case, one professor only teach one. This is a professor. One professor only teach one class. Okay. This is a one-to-many relationship. Okay. When we consider about this relationship, please give me one sec. Okay. In this case, you can see one class can be taught by one professor. එක class එකකට ඉන්න පුළුවන් එක professor කෙනෙක්. මෙන්න මේ class කියන relationship එක entity එක තමයි one class can be taught by, or one class can be handled by one professor. But when we consider about a professor can have one or two or three or four or any number of classes. So you can see professor can have many class as well as professor cannot have any class. So professor gave maximum value එක මෙතන අරන් තියෙනවා අපි 3 කියලා minimum value එක 1. ඒ කියන්නේ අපිට professor කෙනෙක් ඉන්න පුළුවන් class එකක් නැතුව හරි professor කෙනෙක්ට class 1 more than 1 කරන්න හරි පුළුවන්. So you can see this is known as cardinality of this professor. This is known as cardinality of the class. You can interchange. This is just like a 0 many, no? 3 means many, no? More than 1, no? So 0 many, 1 to 1. The maximum of this side is 1. You can write it in this place. When we consider about this case, minimum and the maximum, this is the maximum. You can write it in this case. So one professor teach many classes, but professor cannot have any class. Okay, so this is known as cardinality. Let's take this one. Student enroll in the class. When we consider about one student can enroll in one class or more than one. That means 6. This is the maximum value. This is the minimum value. When we consider about a class can has only a 0 student or 30 more, up to 0 to 35. So this is the minimum number of student in the class. This is the maximum number of student in the class. This is the minimum number of classes for one student. This is the maximum classes for one student. So you can say the maximum number is 35. We can take it as a many. In this case, maximum number is 6. This is also more than 1. So we can take in many. So you can interchange this one and you can provide. Okay, let's discuss about optional and the mandatory in next slide. Okay. That means you can see in some university there are some professors without conducting any classes. At that time, the class is optional for this professor. Okay, that means professor can, as example, let's take a lecture. Professor can conduct or teach. As a lecturer is assigned for one lecture, or professor cannot have any lectures. So that's up to the scenario. So at that time, the lecture entity is optional for professor. You can have the professor කෙනෙකු lecturer කෙනෙකු ගත්තා. professor කෙනෙක් ගත්තාම අපි campus එකේ ඉන්න professor කෙනෙක් lecture එකක් කරන්නත් පුළුවන් නොකරන්නත් පුළුවන්. හරිද? ඒ කියන්නේ ඕනනම් කරන්නත් වෙන්න පුළුවන් ඕනනම් කරන්න පුළුවන්. එතකොට lecturer කියන professor කියන entity එකට මෙන්න මේ lecture කියන එක optional. ඒ කියන්නේ professor lecture එකක් කරන්නත් පුළුවන් නොකරත් ඉන්න පුළුවන්. professor එකට lecture කියන එක කියන්නේ lecture කියන එක අනිවාර්යයෙන්ම නැහැ. අන්න ඒ වෙලාවට අපි කියනවා මේ lecture කියන entity එක optional entity එකක් කියලා. Okay. Then the relationship is an association between entity. You can see we use mostly verb for denote relationship. These are some example: takes, teach, employs. These are some. The student, take, class. You can use noun for define entity, verb for define relationship. Okay. Then there are 3 types of relationship: unary, binary, and the ternary. In this case, if one entity is associated for the relationship, so this kind of relationships are known as unary relationship. You can see this entity is related with this entity. That means cause requires cause. So this is a unary relationship. Okay, one entity is participate for the relationship. In the binary case, 2 entities needed to participate for the relationship. You can see this is the one entity number 1. This is the entity number 2. One entity is contribute to create the relationship between the entity. In the next case is ternary relationship. In this case, 3 attributes get together to form the ternary relationship. So you can define the relationship as a binary, unary, or a ternary. In binary case, one entity. In unary case, one entity. Binary case, two entity, and the ternary case, three entities are get together to form an relationship. Okay. Then the participation constraint. This is about optional and the mandatory case. Okay. If an entity occurs does not always requires a corresponding entity occurrence in a particular relationship, then the participation is an optional. Otherwise, it's a mandatory. As an example, let's take a student follow the module. You can see student can follow more than one modules. There are some cases the students no need to follow any modules, and that time this module entity is optional for this student. So you can denote this optional entity by using this circle. Okay. If an entity occurrence does not always require the corresponding entity occurrence, such kind of entities are known as optional case. In this case, you can say in optional case, this is the optional one. Opposite side cardinality, minimum value is cardinality of the opposite side is that means cardinality of the opposite entity. The minimum cardinality of the opposite entity is equal to 0. If an entity is an optional entity, the minimum cardinality of the opposite entity is equal to 0. Okay. This is also optional. 0.35. That means class එකට students la ඕනම නෑ class එකක් තියෙන පුළුවන් students la නැති. So student is optional entity for the class. Okay. Okay, so these are the main things. Then the object-oriented data model. This is mostly based on the object. So when we consider about object, you can see class and the object concept. No need to have this again and again. We already discussed about this one. The mainly attributes and the methods are available with the object-oriented model. Okay. So these are the main things. Okay, let me. The audio is. Wait. Let's change our internet connection. So there are some technical problems. Okay. Please give me 1 second. Okay, I think now it's okay. Okay, then we need to have some idea about mapping ER. Okay, there are two options. Now we can discuss about our paper or ER diagram. What is the most preference one? Mapping of the ER diagram or discuss about the paper. What is the best option?
ER diagram.
Okay, mapping. What about others? Okay, let's discuss about ER diagram first. After that, we can move into paper, not a ER diagram. I think now you can now all the theory parts are covered. You can create a ER diagram, but the relational model, you need to have some idea about how to map the entities into relational model. Okay. Yeah, definitely I'm discuss about paper. So in this case, mapping of the strong entity, you can map a strong entity into a relational model like this. You can see this is a strong entity customer. You can provide customer ID, customer name, customer address, and the post. Okay. Before that, let's try one question from the paper. Again, move into the theory part. Okay. You can try this one. This is a question number 1. You can try this question. Question number 1. Draw to appropriate relation schema for the following ER diagram. You can try this one. I will give you, this is 2 paper, no, it's only 4. That means 30 minutes. You can just go through this question and try to map this one first. I will give you 10 minutes. Try this one. මම කියලා දීලා වැඩක් නැහැ. ඔයාලා try කරේ නැත්තම්. මොකද paper එක කරන්න exam එකේදී ඔයාලා විතරනේ මම නැහැනේ. ඔයාලට පුළුවන් විනාඩි 2-3ක් අරන් ඔක try කරන්න. First question එකම try කරන්න පුළුවන්. අපි ඔක්කොම කතා කරලා ඉවරයි. Do you have this paper? This is final examination paper 2017 and 2018. Do you have this one? ඔයාලා ගාව මේ paper එක තියෙනවද? No one in the class. Okay. Okay, I will upload into your chat. Yeah, this is available at the chat. Not chat, learn or use it. Okay. You can download the paper. It's available in your chat. Okay, you can try. Try this one. I will give you 7 minutes. 250, up to 250. You can try this one. Draw a first question. Briefly describe the difference between data and the information. What is data management? What is database? What is metadata? Describe the following 3. These 3 and this one. You can try up to 250. Let's discuss this question at 250. I will give you 6 minutes to go through this one. You can drop your questions into the chat while you're doing this one. While you're doing this paper, you can drop your questions. I can answer the questions. Shall we discuss? Shall we discuss? Okay. The first question is briefly describe the difference between data and the information. Who is going to answer this question? Sassarani, what is the difference between data and the information? Don't leave the session. Okay. Can someone answer my question? What is the difference between data and the information?
Data is a raw fact and it won't provide any meaning.
Yeah.
Information is a processed data and it will give a specific meaning for it.
Okay. Then what is the data management? We already discussed these things in this lecture. So what is data management?
It's a discipline that focuses on proper generation and storage and retrieval of the data.
Yeah. Then what is the database? Simple questions.
Collection of related data.
Yeah, metadata. What is
Description of the
description
of the data characteristics and the set of relationship link the data found within the.
Okay. Then okay, next question. Describe the following with respect to database. What is a field? Can someone answer my question? What is a field?
Collection of characters which give a meaning.
Yeah. Then the record.
It's a collection of attributes of fields.
Yeah. Then the file. What is a file?
Collection of related records.
Collection of related records. Okay. Then what is meant by database management system? DBMS. What is meant by what is a database management system?
It's a set of programs that enable the user to create and manage a database.
Then the database system. Simple questions. What is a database system? Go ahead. Sofna, I think. What is a database management database system?
It is a system of DBMS and database.
Yeah, DBMS and the database collection of DBMS and the database management system. Okay, so then let's discuss about 8th question. Draw a appropriate relation schema of the following ER diagram. How many students did this one? Is it, I'm going to discuss this one. What about theory part of this one? Do you have some idea about how to map in an ER diagram into relation schema? Can you map ER diagram into relational schema? ඔයාලා මැසේජ් එක දාන්න chat එකේ දැන් මේ question එක කරපුවා ඇතද කරපු නැති ඇත්තද මේකේ කොහොමද map කරන්න කියන එක discuss කරන්න ඕනිද එහෙම නැත්නම් question එක මේ කවුද කරන්න ඕන කියන්නේ මේක කරන්න ඕන කට්ටියක් තියෙන කියන්නේ theory part එක කරන්න ඕනද නැත්නම් question එක විතරක් discuss කරාම ඇතිද
Need the theory part also.
okay okay structured query language SQL standard for structured query language structured query language okay 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 let's discuss about how to map in an ER diagram into relation schema this is very important mapping ER into R scheme that means relation schema is very important in your level so first of all let's see how you can map a strong entity into a ER that means a relation schema in ER diagram you can see this is a customer entity is consist with customer ID it is the primary key of this field then the customer name and the customer address and the postal code okay so this is the entity customer entity these are the attributes now we are going to map this strong entity this is a strong entity you can see this is not a weak entity this is a strong entity now we are going to map this strong entity into relational model so you can take this relation as a customer relation or a customer table in this case customer you can see this is a strong entity you can include all these attributes and you need to mention the primary key in a strong entity you can map all the attributes into a relationship itself okay so you need to indicate the primary key of this relation you can see that relation is a customer relation is consist with these 4 attributes customer ID is the primary key okay then the composite attributes now we are going to discuss about our attributes this is about a strong entity now we are going to discuss about composite attributes let's see how you can map this composite attribute into relation schema okay you can see when this customer entity this is consists with customer name in the customer address then postal code, and yeah, when we consider about customer address, it is subdivided into street, city, and the state. Okay, now we are going to map this into a relation schema. When there are some composite attributes, you need to map all the simple attributes. That means all the single attributes. When consider about this is a address is a composite attributes, but we indicate street, city, state in the relation schema. We does not discuss about customer address, but we discuss about street, city, name, in state in the relation schema. You can see in this case customer ID, customer name, then the city, street, state, postal code are the attributes of this customer relation. You can map composite attribute by using their simplest form. Okay, so this is the way you are mapping composite attribute into relation schema. Okay, then let's move into the next one. Multi-value attributes. So the telephone number is the best example for multi-value attributes. You can map multi-value attributes in another schema by using another schema. You can see this is an employee. Now we are going to discuss about multi-value. Okay, in multi-value case, this is the entity, employee entity. Employee entity is consist with employee ID, name, address, and skill. Skill is a multi-value attribute. That means you can have many skills: listening, then the sleeping, reading, dancing, learning. These are some skills. So this skills attribute is a multi-value attribute. Okay, in this case you can map this multi-value attribute separately. You can create two separate schema for this entity. The one schema is as a employee ID. It is consist with employee. It is consist with employee ID, name, and the address. So this is a one relation. When we consider about a multi-value attribute, you can create another scheme as an employee skill. This is the name of the multi-value scheme. You can see we can include this attribute skill, and you need to include the primary key of this entity. So the employee ID is the primary key. So in the multi-value attribute, we create a separate relational schema with the primary key of the entity and the multi-value attribute. You can take these two as a composite key. Okay, so this is very important. You need to create a new relationship for multi-value attribute. Okay, new relation schema. Then discuss about mapping weak entity. You all know if an entity is totally or partially depend on another entity, such kind of entities are known as a weak entity. So this dependent is a weak entity. Employee, this is the relationship. Employee claims dependent. So dependent is totally depend on this employee entity. So this is a weak entity. In ER diagram, we can denote weak entity by using a double line, rectangle. So let's see how you can map this into a relational model. So relation schema. In this case, this is a strong entity. We can just map strong entity. Employee is the relation. Employee ID, employee name is the two attributes in this employee entity. So employee ID is the primary key of this relation. When we consider about a dependent is consist with first name, middle name, last name. This is a composite attribute. So we can map the simplest form of the composite attribute: first name, middle name, last name, and date of the birth and the gender. But in the weak entity, this weak entity is totally depend on this one. So you need to include the primary key of this strong entity in the weak entity relationship. So you can take this employee ID as the primary key of this table. This is from strong entity. So this is a weak entity. You can include primary key of the strong entity in the weak entity. So all these four can be considered as the composite key. Okay. Okay. So this is about how to map a weak entity, then the strong entity, normal attribute, then the composite attribute, and the multi-value attributes. In multi-value attributes, you need to create a new relation schema. In weak entity, you need to include the primary key of a strong entity as the attribute of the weak entity. So this is the main thing about mapping ER diagram, mapping entities and the attributes. Then let's discuss about how to map relationships. When we consider about relationship, there are three types of relationship: one-to-one, one-to-many, and many-to-many. In one-to-many relationship, you need to include the primary key of one side as the foreign key in many side. You can see when consider about this one, customer and the order. This is a customer submit order. This is the relationship. So this is the one. Yeah, this is the many. This is a one-to-many relationship. In many sites, you need to include the primary key of one side. So the customer ID, customer name, customer address, postal code. In the customer, this is a strong entity. Order is also a strong entity, order ID and the order date. But when we consider about the relationship time, this is one-to-many relationship. You need to include primary key of one side in the many. So customer ID, this is as a foreign key. You can include the foreign key. That means primary key of one side can be included in the many side as the foreign key. Okay, this is very important when you are mapping one-to-many relationship. Okay, you can refer like this. This customer ID refer for the customer ID in customer table. Then M-to-M relationship, that means many-to-many relationship. In many-to-many case, you can see this is a many-to-many relationship. Customer ID, you can map it as a employee ID, employee name, birth date, then the customer course title, course ID. This is the primary key. These are the two entities. But when we consider about this one-to-many relationship, you can map another in many case. You need to have this relationship as like this. So you need to map this one as, this is also a special kind of, what is the name for this one?
Composite entity.
Composite entity, yes. This is a composite entity. So in many-to-many relationship, you can define this relationship as a composite entity. So you need to map another relationship for this composite entity. So this is, in this composite entity, there is a attribute as a date complete. So you need to map a separate relationship for composite entity, course date complete. Only one attribute, date complete, but you need to indicate primary key of these two sides in this relation. That means primary key of a strong entities as the attributes in the composite entity. Okay. Then the next one is one-to-one relationship. This is also very important. When two entities are in one-to-one relationship, you need to create two relationships for separate relationship schema for two entities. Primary key of one side of the relationship is included as the foreign key in the other relation. You can see when consider about this one, nurse and the care center. Nurse, these are the attributes, customer ID and the birth date. So this is not a, so this is not a mandatory, no, this is an optional one. Care center, customer ID, location, date assigned. So you can see. Yeah, in this case, it's considered about mandatory and the optional case. This is not a this example. In this case example, you can see this is a optional entity. This is an optional entity, one-to-one relationship. At that time, you can create two relations as a nurse and the care center. You can include all these attributes with the primary key in the nurse relationship. Then in the care relationship, care ID and the location, you can include nurse ID. You can take this as a nurse ID. This is optional side. In optional side, you can insert the primary key of mandatory side as the let's take this as the foreign key. Okay, then the data side, this one. Likewise, you can map your ER diagram into relation schema. Definitely, you have some one or two questions from mapping ER diagram into relation schema in your exam paper. So, what is the answer for this one? You can see there are two strong entities as the patient and the doctor. When we consider about doctor, doctor is consist with doctor ID as well as doctor address. Doctor address is consist with it is a composite attribute. Then this relationship is one to many. There is an entity attributes for the relationship as a tree date. Then there are two attributes for the patient entity, patient name and the part ID. So what are the relationships in this ER diagram? How you can map this ER diagram into relation schema? Okay, can someone answer my question? Let's
First, if we take doctor one, the attributes are doctor ID and street and city.
Wait, Buddha. Give me 1 second. Okay, doctor. Let's take doctor. This is the relation. When we consider about doctor, so what are the attributes available in this relationship? Doctor
ID.
Then what are the other? City. Then
street.
Next street. Okay. So what is the primary key? Doctor ID is the
doctor ID.
Is the primary doc ID. Okay. Okay. So then what is the
patient?
Patient. Okay. When we consider about patient, what are the attributes available in patient relationship?
Patient ID.
Patient ID.
Patient name.
Patient name. Okay. Then?
And doc ID will be function as a foreign key.
Yeah. Doc ID can be function as a foreign key. You can refer like this. Make patient ID is a primary key. Then there is a. Are there any other relations?
That's a relationship attribute, but
When you are mapping a relationship attribute, you need to create another relation. Okay. Yeah, you can take another relationship as a treatment. When you are mapping a relationship into a relation schema, you need to give a name as a noun. Okay, this is a treat. No, treat is a verb. You can map these treats as a treatment. Okay, so this is the relationship name or a relation scheme, name of the relation. So you can see there is one attribute as a tree date. Wait, it's difficult to write. Tree date. Okay. Then in this case, you can insert primary key of this site and the primary. So this is a relationship. Yeah, that means attribute in the relationship. Now we create a attribute. We create a relation for this relationship. So you need to indicate doc ID as the primary key and the patient ID as the primary key of this relationship. This is the entity. Yeah, doc ID and the patient ID is the primary key of this treatment relationship. TR date is the another attributes in the treatment. If this is a composite attribute, you can create another relationship. This part is not covered in this slide set, no? Relationship attribute, but I remember that I discussed this
They
thing.
have only mentioned for the many-to-many relationship.
Sorry?
They have only mentioned the relationship attribute for many-to-many relationship,
Yeah, ready to.
not for the ones.
Yeah. But I think I discussed these things in your lectures. Please refer lecture videos. I think I discussed with some examples. Okay. I remember that I discussed this example in your class. In this case, I definitely, yeah, this is one-to-one. There is a, so definitely I discuss about this attributes in the relationship in your class. Please refer those records, okay? Okay, then let's move into a second question, question number 2. This is about diagram mapping and the normalization. Shall we discuss this one also? Is it okay? Or yeah, what about your choice? Let's discuss question 2 or question 3 or question 4 or question, I think it is question 5. Let's discuss this one. Okay, question number 2. You can try this one first, okay? I will give you some times. You can try. Then let's discuss together, okay? Try this one, question number 2. ඔයාලා මේ question number අපිට question number 2 එකත් cover කරොත් අපිට cover වෙනවනේ මේ ටිකක් මොනවාද normalization part එක. දැන් ඒක move කරගෙන skip කරන් ඊළඟ question එකට අපිට normalization කතා කරන්න අද වෙලා මත වෙනවා. ඒ නිසා normalization ටික cover වෙන නිසා අපි මේ question එක කරමු. 3:18 I will give you. Let's discuss this question at 3:30. Try this one. This is from the normalization. This is the theory part. This is also theory part. This is about mapping relation schema. Try to map this one. At least try to map this one. Okay. Try this one. Let's discuss this at 3:30. You have 10 minutes to write the answer for this question. Okay. Try this. Okay, shall we discuss this one? What about your progress? Did you finish it? No one in the class? Okay,
Doing, madam. Doing, madam.
okay. I will give some time. Tielina, can you send me your answer, madam, when we continue? Finish PC on table again. Tanya कैसे पकड़ा? हाँ. Okay, let's discuss. What is the answer for first question? What are the state three types of software that need to make the database function fully and describe each of them briefly? What are the three types of software? What is the answer for first question? What is the three types of software? Did you find the answer for this one? Can you all?
Operating system
Huh?
software, DBMS software, and application program.
Yeah, operating system. Wait. Operating system software, DBMS software, and the application programs and the utilities. You need to provide some description about these three types. Okay, operating system software, DBMS software, and the application, program, and utilities. Okay, then what is the normal form? Okay, what is the normal form of this table is currently in? What is the normal form? Yeah, it's in first normal form. Okay, what is the partial dependency? If there are any partial dependencies in the above diagram, identify and mark them. So what is the partial dependency? What is the partial dependency?
If an attribute only depends on the part of the primary.
Yeah, part of the composite key or a prime attribute. Okay. Then, so what is the partial dependency in this diagram? Identify the partial dependency.
B and C are dependent on A, and E and F are dependent on D.
B and C are depend on A, and which one? D and E and F are depend on A is depend. So what is meant by transitive dependency? Please give me 1 second. In partial dependency, I'm going to share the note with you. Yes, note. This is about data normalization. Okay. Data normalization. You can see this is the partial dependency. Dependencies based only the part of a composite key are known as a partial dependency, or dependencies based on the part of the composite primary key is called as a partial dependency. You can see in this relationship, this project number and the employee number is fully, these are the two primary keys, that means composite key in this table. So this project number depend on this project name, depend on project number. So this is a partial dependency. When we consider about this one, this is also employee number. It is depend on change hours. So change hour depend on employee number. So these are the two partial dependencies. Okay. So what is transitive dependency? Can someone answer my question? Non-prime
An attribute depends on a non-prime key.
non-prime attribute depend on the non-prime attribute. Yeah, you can say in this case, this is a job class. This change hours depend on job class. So this is a transitive dependencies. So in your example, what are the transitive dependencies?
C is dependent to B and F is dependent to E.
Wait, E is depend on F, G is depend on, yes, G is depend on, this is not a transitive, sorry. E is depend on F, this is one transitive. This is also correct. C is depend on B. There are two. This is not a transitive. This is okay. Yeah, only two transitive dependencies. Is it correct? This is a partial. This is a partial. Is it correct? Yes, there are two transitive dependencies. So this is in the first normal form. You can convert this into a, first you need to convert this into a second normal form. Okay. Convert. What are the relationships in the second normal form? You can drop a message. This diagram is in first normal form. Then you can convert this diagram into second normal form by eliminating the you can convert this into a second normal form by you can consider about partial dependencies when converting first normal form into a second. Madam, for partial dependencies, GH, wait, partial dependencies, G to D. This is not a partial dependencies. We cannot take it as a partial dependencies. We can consider G to D, that means opposite of the transitive dependencies in B, C, and F form. Okay. This is a one kind of partial dependencies. ඒකට කියන නම මට හරියට මතක නෑ අනිත් පැත්තට වෙන එක. මේක අපිට partial dependencies එකක් විදිහට first second normal form එකේ eliminate කරන්න බෑ. මොකද මේක යන්නේ non prime attribute එකකින් G prime attribute එක. මේවා අපි eliminate කරන්න BCN form එකේදී. Okay? හරි. Can someone answer my question? What are the relationships available in second normal form? කොහොමද අපි second normal form එකට මේක convert කරන්නේ? What are the conditions that the relationship to be in second normal form?
Have to eliminate the partial dependence.
Yeah, partial dependencies. So how you can eliminate the partial dependencies? Three tables, okay. You can create three tables. So what are the attributes in each and every table? ඔයාලා කරේ නැද්ද මේ ප්‍රශ්නේ? නැත්නම් ඇයි ආන්සර් එක දෙන්නේ නැත්තේ? දැන් මම කරොත් වැඩක් නැහැනේ. කතාන්ස් එක. First normal form එකේදී අපි දැන් first normal form එකේ තියෙන ER diagram එක අපි දැන් ඒක convert කරන්න යන second normal form එකට කොහොමද convert කරන්නේ? You can eliminate the partial dependencies. So after eliminating, what is the output? Yes, Tanushan.
Yeah, breaking the table into three tables.
Yeah.
So each table will contain the primary key. As first one is going to contain A.
A is the primary key of first table. Yes. Then what are the other attributes in the first table?
B and C.
B and C. Then the next one?
Second table will have the primary key as D.
D. What are the attributes?
E and F.
E and F. Then next one?
It is going to be a composite key, A and D.
E. What are the attributes?
G and H.
D and H. Very simple. You can create a three relationship or a three tables. You can give any name for three tables. Okay, table 1, table 2, table 3, any name. So in first table, 3 attributes A, B, C. A is the primary key. In second table, D, E, F. D is the primary key. In third table, A, D combine together to form a composite key. G and H are the other attributes. So this is in second normal form. Then let's convert the second normal form into third normal form. So what is the requirement to convert this one? What is the requirement to, that means what is the main requirement?
By eliminating the transitive dependency.
Transitive, you can eliminate the transitive dependencies in second normal form to convert it into a third normal form. So what is the output? Simple, no? What is the output? We already eliminate partial dependencies. Then eliminate transitive dependencies. So what are transitive dependencies? C depend on P. Then the next one is F depend on E. කොහොමද eliminate කරන්නේ? I will give you 1 minute. You can refer this note and the answer. Conversion second normal form into third normal form. This. What is the answer? Rasnia. No, not Chrysania or someone. What is the answer?
Again, creating a new table.
Oh yeah, new relation. Okay.
So in that table, B will be the primary key.
Okay, then what are the other attributes in the table?
C.
C. Then the next one.
Next one.
There is another transitive.
E will be the primary key.
And the F is the other attribute. So this is now in third normal form. Then let's discuss about already it's in third normal form. Then BCN F4. Is this in a BCN form or not? Or is called normal form? We already did this one. That means first normal form. Then already eliminate this one, this one, and this one. There is another dependency. Okay, madam, can you please draw and show the third normal form? You can, you can write it like this. Wait, like this. You can write it like this, so you can draw it. Okay. Okay. Please give me 1 second. Where's my, this one. Okay, in third normal form. Can you all see my whiteboard?
Yes, ma'am.
Okay. I'm going to draw. Let's write it. You can draw it, no? You can mama ලියන්න ඔයාලා එක draw කරන්න මොකද මෙතන මට draw කරන්න ඉඩ මදිනේ මම ලියන්න in first table. Let's take like this. In table 1 you can see A then the B, C. Okay. In table 2, you can see D. This is the primary key, E and the F. Okay. In third table, you can have composite key A and D, then other two attributes. Now this is in second normal form. We eliminate all the partial dependencies. Then let's move into table 4. You can, yeah. In third normal form, there are two transitive attributes as B. Transitive dependencies B, C depend on B. We can, that means non-prime attribute depend on non-prime attribute. So we take this as a primary key, B as a primary key. Now it's already eliminate the transitive dependency. Then the next one is E, F. This is the next table. Okay, so you can draw this table like this: T1, A, B, then the C. Like this you can draw. Okay. So this is the answer for this one. Fernando, I think. To the number RGA Fernando. Is it clear? Okay. Okay, then BCN4. So how you can convert this into a BCN4?
By making the G as a primary key.
Yeah. If you take G, only G or a composite key?
Composite key with A.
Key with which one?
A and G.
What about D? D is also prime key now. If you take these two, again this is become to first normal form. No?
Yeah, but we can separately indicate that G is dependent on D.
Yeah, like this. G is depend on D. This is a non-prime attribute. Sorry. There is another dependency. Wait. ECN form. What is this one? SPCN form. Table content candidate is 3M.
Ma'am, excuse me.
Okay, go ahead.
Okay, by converting this BCNF form, we are
Yeah.
actually only going to take that third table, which have the composite key as A and D, isn't it?
Sorry.
So we are going to convert it to BCNF now, ma'am.
Yeah.
So in that process, we are going to take only the table which has the composite key as A and D,
Yeah.
not the other two.
Yeah.
That's what I am asking. So we are only focusing on that particular table, not the other table.
Yeah. Only a particular table. So you can see this is a prime attribute. Non-prime attribute depend on non-prime attribute. So how you can eliminate this one? This kind of things. You can see this is a B, then the C and D. You can see C depend on B. B is a non-prime attribute. So you can eliminate this one like, yeah, this is in the C to B, no? So you can create this one. Plus C plus D indicate then. In this case, if G. Wait, please give me 1 second. This is in. Example in your slide. Please go to this example. In this example, you can see this is the table. This is the third normal form. A, B depend on A, B composite key depend on C. Sorry, C and D depend on A, B. Then C depend on B. You can see in this case there is a dependency as non-prime attribute. Prime attribute depend on non-prime attribute. In BCNF form, you need to eliminate such kind of dependencies. Okay, so you can see this is the diagram. So if you need to eliminate this one, you can make this as a prime attribute. At that time, it's definitely moved to the first normal form. You can take this C as a primary key, then the B. Okay. Now C is depend on B. Another partial dependency with this one, and A plus C can A plus C can B and D denote determined by A and C. Okay. Then you can convert this into 3NF form again. A can see A and C, then the D separately and C and B separately. In your example, this example, you can take this as, this is the relationship now G to D. You can eliminate this one and this one, G to H. Okay, then it's moved to the first normal form. Again, you can convert this into a second normal form, then the third normal form, second normal form, and the third normal form. In this case, share this one. Okay. In T5, T6, you can see what is the attribute? G to D, no? G එකයි D. You can take G and D. Participation G plus D, no? Then D is not a primary key of this one. Okay. Now there is a conflict with this relationship. Okay. conflict with this one. Okay, so you can make this as T3, you can rearrange as A, then G, AG as the composite key, then D and H as the primary key. So okay, this is also okay, this is also okay. And you can convert like this, and you can indicate E and F in this relationship. You can eliminate this one. Is it clear?
Excuse me, madam.
Okay.
Can you explain once again?
Okay, wait, the momentic cap one. Let's take this relationship T2. Okay. In your first exam, again from the beginning, in the first, you can eliminate T1, A, B, C. Okay, this one. A, B, C. T2, then B, sorry, not B, D, E, and F. Okay, then T3, A, D, and G, H. This is in first normal form. Then all the partial dependencies are eliminated. Then transitive dependencies, B, then the C, then T5, E, and the F. Now this is in third normal form. Okay. Then now we have another relationship as what is the relationship? G to D. D is a prime attribute. This is a non-prime attribute. So you need to convert this in BCN form. This relationship is in third normal form, but not in BCN form. Now I'm going to convert this into BCN form. You can say G, sorry, this is not a prime attribute. So this is a prime attribute. To convert this one, I'm going to make G as the primary attribute and D as the non-prime attribute. Okay, make a called relationship 5 T6, not 5, 6. Now you can see this D1, and there are two relationship, there are two tables conflict with this one. දැන් ඔයාලට පේනවා අපි දැන් මෙතන BCNF එකට ආවට මෙතනදි මේ ප්‍රශ්න නිසා ආයෙ මෙයා යනවා first normal form එකට. හරිද? first normal form එකට යන නිසා දැන් ආපහු මෙයා යනවා partial dependency එකක් තියෙනවා. හරිද? මෙතන partial dependency එකක් ඇති වෙනවනේ. මොකද මෙයා G නේ primary key. ඒතර මෙයාව primary key වලින් අයින් වෙනවනේ. wait. මෙයාව primary key එකකින් අයින් වෙනවා. මෙයාව primary key එකකින් අයින් වෙනවා. හරිද? එතකොට ඔයාලට පේනවා again මෙයා යනවා first normal form එකට. හරිද? Now this is again in first normal form. To convert this into a third normal form, you can take G as the primary key of this relationship. So you can see these two are composite key, A and G. Now D and H is depend on A and G. This is okay. When we consider about this one, D, E, F. Okay. Now D is not a primary key, but in this relationship, D is not a primary key. E and F, all these three, when we consider about all these three, no primary key in this table. Okay. You can insert G. There are two ways. You can insert G as a primary key of this one, or you can insert this E and F into this relationship. This is very easy. You can insert E and F into this one. Okay, then now E and F, G, these are the two composite key. Now this is in first normal form. No issues from transitive dependency. Second normal form. Sorry, third normal form. Now this is in second normal form. third normal form. This is in BCN form. Now it is okay. Harita. Yes, my lecture not. Is it clear?
Ma'am, excuse me.
Okay, go ahead.
Yeah, after we complete 3NF,
Oh,
so we can say that table 1, table 2, and table 4, table 5. Those are in BCNF form. Only the table 3 is conflict.
sorry.
Can we say that table 1 and table 2, table 4, and table 5? Those are already in 3NF and BCNF.
One. Say
1, 2,
one,
4.
2, 4 and 5. Okay. 1, 4, 5.
Not this one, ma'am. Previously,
In previous case.
yes, ma'am. Not this diagram.
Okay. In previous case. Okay.
So we are going to do the BCNF part, only the table which is going to conflict with that dependency.
Yeah. Only the conflict in the, yeah.
So in here, table 3 is the only one which is conflict with BCNF.
This is on in this T2. Table 3 is only the conflict, yes.
So the rest of the tables are 3NF and BCNF form.
Yeah.
Yeah, that's why, ma'am. That's what I'm asking.
Yeah. This is T2. It's not in a conflict. Okay. You can keep it like in the first form. Then you can change the T3 in third normal form. You can eliminate the partial dependencies in T3. Okay.
Okay, ma'am.
Okay. So you can go through this example. There are finally you can see T1 ABC, T2. What are the elements? I think E, F, B or something. Then the T3 A, G, H, E, D. Then T4 BC, T5 is F, T6 G, D. So this is the final answer. Okay. Then there is another question. Wait. I can't see. It's that one. Can you see my screen? Can you all see my screen? Wait. It's not going to give the permission to share it. Wait. I'm going to close the whiteboard. Then these three. Then let's see. Okay. Oh, okay. Okay. Then let's move into next question. Question number 3. What are the 5 types of users in the database? Sorry. Yeah. What are the 5 types of users in database system? No need to describe it now. No need to describe the task of them now. What are the 5 types of users? What are the 5 types of users? Who are the 5 types of users in the? Yeah, all you need. Go ahead.
Is it about that the people who involved with the database system?
Yeah. Who 5 types of users who use the database system or users? Person.
System database administrator.
And database designer, then the system analyst and the program and the end user system.
System analyst and program.
Yeah. system administrator, database administrator, database designer, system analyst or a programmer, then the end user. 5 types: system administrator, database administrator, database designer, system analyst, and the end user like us. Okay, you need to provide some task of them. All these are available in your lecture slide and the book. You need to describe the task of these 5 users. Okay, then let's move into the CR diagram. Did you do this?
What's the question, ma'am?
Question number 4. Consider the CR and draw the appropriate relation scheme for the given ER diagram. Did you do this?
No, ma'am, not yet.
Okay, you can map this into a relational schema. I will give you 5 minutes. This is very important. In your exam, definitely 2 or 3 questions from this relational schema. Yeah, this is the answer for the question. SW Vijay Singh. Yes. We are going to create your paper from all the units up to SQL. I think it's 21 or 20, from 1 to 21. Lesson number 1 to 21 or 20. I don't remember it. No need to go with join tables, join queries up to simple queries, the complex queries, SQL. I will give you 5 minutes. You can map this. Lesson number 1 to 21 for final exam, not from the old book.
Excuse me, madam. 21ක් දෙනවද නැත්නම් 21 නැතුවද?
මට 21 lesson එකේ නම් topic එක පොඩක් කියන්න පුළුවන් මොකක්ද කියලා මට.
Understanding dates and time.
එතනට එනකම් එනවා. 21 dates and times අපි කරා class එකේ. Yeah, understanding dates and time. Join tables inquiries එන්නේ නැහැ. 21 වෙනකම් එනවා. Okay, shall we discuss this one? Did you finish this question? Only 59 students. Okay, let's discuss this one. First, let's take. There are 1, 2, 3, 4 attributes. Okay. Well, let's take, sorry, not attributes, entities. Let's take entity A. When we consider about entity A, it's a strong entity. You can see it's a strong entity. Let's write this like, this is a relation schema. No? Let's take relation 1, relation 2, 8. I'm going to write it in this R1. In R1, you can see, not R1, wait. Let's take this as A. A, in attribute A, in entity A, you can see A is the primary key. Okay. Then let's discuss about this one. This is also a strong entity. Entity C, CC is the primary key. Okay. Then B is the primary key, and DD is the primary key, and there is another attributes as D is it. Okay. Now we are ready. Okay. Then when we consider about this attribute, this is in B, no? B, there is another attributes as a multi-value. In multi-value attribute, you need to create a new relationship. So let's create it as BB is it, new relationship. In new relationship, BB is the primary key and B is it. These together to form primary key. These two get together to form a composite key. Okay, so this is about BBC, this relationship. Okay. Then all the attributes. Okay, before that, in this case, in C, CC is a primary key. There are two attributes as a CX and CY. Okay. In this case, DD and the DC finish, A finish. Okay. Then let's discuss about this one. When we consider about this one, 1 to N relationship. Yeah, when consider about 1 to M relationship, you can include the primary key of one side in many side as the foreign key. So in C relationship, we can take this as a foreign key and we can make a relation like this. Okay. So this is also okay. Then let's consider about ACX relationship attribute. In this case, you can create a ACX. In this ACX, sorry, not ACX, AC relationship is AC. You can take any name, AC1 or AC2 or AC, any name. AC, there are two attributes as a ACX. You can take a primary key of this side and the primary key of this side as the primary key in this relationship. AA and the CC are the primary key of this relationship. Okay, like this. Now it's okay this side. Then let's discuss about this relationship, 1 to N relationship. You can include primary key of one side in the many side as the foreign key. So DD also foreign key in this CC. So this is not a C relation. Okay. Then let's discuss about one-to-many. Let's discuss about this one, CDX. We can create another relation as CDX is an attribute. We can include these two as the primary key, CC and the DD. Okay, this is also finished. Then let's move into this one. In this case, you can see this is many-to-many relationship. So this definitely this is a composite composite attribute. You can create another relationship as a BD. In composite case, you can include BDX and BZ and sorry, not BZ, BB, and this is DD as the primary key. All these three get together. This is a composite attribute, so this is definitely become a primary key. All these three take as a primary key. Okay, then now this is also finished. Then let's move into this one. In this case, A, then the B, this is an optional one, and there is a relationship as a BX. First, let's treat this optional one, AB one. In AB relationship, this is the optional, no? In this side, B side, this is optional, so you can include A and ABX as the foreign key of this relationship. Okay, then when we consider about this attribute in the relationship, you can create another relation AB, then the ABX, then this is the AA is the primary key and BB is the primary key. Okay, I think I consider all the cases. Yeah. Are there any other relations? Are there any other relations? Are there?
Ma'am, excuse me.
Okay.
When we consider that optional entity,
Yeah.
is it actually going to have the primary key of the A? Because weak entity, no, ma'am.
Sorry?
Usually weak entity is the one which have the primary key of the A. So here this is an optional one.
Yeah, it's a foreign key, not a primary key. The dotted line.
Okay.
In relationship, it's not a primary key, dotted line. Foreign key.
Okay, ma'am.
Not a primary key, foreign key. This case. Last one, wait. This one. You can see in this case, this one. This is an optional one. You can include the ID as a primary key of this one. This is the case, not a, sorry. Not the primary key, it's a foreign key. There are two foreign keys, this one and this one. In this case, there are two foreign keys. In this case, also foreign keys.
Ma'am, excuse me.
Okay.
Then what about the ABX? That when we marking about entity B, we have all included ABX within that.
In which case? This one.
B entity.
This
B entity.
or B relationship.
No, we're B entity. Yeah, when we
In
within that there is a ABX attribute.
this
That's a relationship attribute, no? What?
make on. This is not necessary. Sorry. This is AA. BB is the primary key.
Okay.
A is the this one. B set up here. BB is it. Yeah. Multiple. Make on. Only BB and AA is the foreign key, and you need to refer. You need to provide this one line by line, and you can make the reference by using arrow. දැන් මම මෙතන ඉඳලා මත නිසා තැන් තැන් වල මේව කරාට ඔයාලා මේ පිළිවෙලට ලියලා arrow එකක් මේව ගන්න කොහෙන්ද refer කරන්න කියලා. Yeah, when we consider about it's only this one. In A table, it's only a primary key because these two cases, this is in one side. Okay. And again, you can take CC as a foreign key. This is a one-to-one relationship. No, if you need to provide the relationship between this one, so you can take CC as a. This is optional entity. It's already done. When we consider about no, this is not a one-to-one. Sorry. This is one-to-many. Only this one. AA. I think it's one-to-one, not one-to-one. It's one-to-many. Table A only has AA. Okay, then let's move into next question. Now it's already 4:30. We have only 50 minutes. Okay. Consider the following table. So find the output of these four operations. Let's discuss some SQL part. This one. What is the output of this one? A divided by B. Do you have any idea about Boolean algebra? Relational algebra, not a Boolean algebra, relational algebra. We discuss about intersection, union, divided, then the difference, intersection, product. All these operations. We discuss about all these operations. Do you have any idea about them? How you can find the output of A divided by B? A divided B.
The entity occurrence within the B,
Hmm.
that both things should be associated with the non-shared attribute, which is DSI, I think.
Shared attribute divided. Let's take what are the two tables, A and C. No, not A and C. A and B. Okay, you can find divided operation 39, 42. So you can see 39. So what is the output of this one?
DSI.
DSI. Yeah, output is DSI. So you can see when consider about this divided, it is needed to have one table with one attribute and another table with two attributes. This is the minimum requirement. Okay. So you are going to find then A divided by these are the two tables. In this table, two fields. In this table, one table. One column. Now you can find in B, A divided by B. Now let's consider B. There are two values, 39 and 42. Then you can find what are the available shoe size as 39 and 42. So these are the two shoe size. So these two attributes are same. If these two attributes are same, so this is the output of this divided. Okay, you can move into divide operator. This one is the divide, last one, I think. in divide operators, it is required to use one single column table and the two column table, and to be include the result, the value in the non-shared column must be associated with every value in the dividing table. So you can see in this example, this table is going to be divided with this table. This is consist with A and B. You can see A and B, these 5 data, these 3 data with A, this is B. But when we consider about these 3 and these 3, there is a one common attributes. You can see 5. So the output is 5. In this case, it's only a value in the non-shared column must be associated with every value in the dividend table. So 5 you need to associate. When we consider about 5 you need to associate with A and B. At that time, it's the output. When we consider about 9, it's only associated with A. So this is not the output. When we consider about 4 is also only associated with A. So this is not the output. When we consider about 3, it's only associated with B. So this is also not the output. So the common attributes is the output of A divided by B. So in this case, DSI is the common attribute. So this is the output. Okay. I think it is clear. Okay. Then C difference D. Consider C. This is C and this is D. So what is the output of this code?
Jeep and bike.
Sorry?
Jeep and bike.
Jeep and bike. C difference D. Jeep and bike.
Sorry, ma'am. C difference D. No.
Oh yeah, C difference D, no C table. These
Then van.
sorry?
Then van, bus,
Van,
tipper.
bus, tipper, yeah. In this table, let's find the common attributes. What are the common attributes? You can eliminate the common attributes. Other attributes are the output. Okay, so you can wait. You can say this is C difference D. So car, van, lorry, bus D. So this is the data set. Let's consider this data set. Car is available in this one. So this is not the output. Then the van is not in this. So the van is the difference one. So the van is output. Then when we consider about lorry, it's in D. So it's not the output. Then consider bus. Bus is not in this one. Yeah, but is not in this one. So the bus is also output. When we consider about tipper also not in this data set. So the tipper is also an output. So these 3 are the output of this C difference D. Van, bus, and the tipper. Okay. Then what is the output of C intersect D? Consider two tables C and the D. What is the output of C difference D? Yeah, C.
Car and lorry.
C intersect D. Yeah, the common attributes of these 2 tables. So the car and the lorry are the common attributes of this car and the lorry is available in these 2. So these 2 are the common common data for these 2 tables. So the car and the lorry is the intersect of car and the lorry is the output. Then E product D.
Madam,
Yeah.
E intersect D. Now, when it's saying car and lorry, does the number of wheels also come, or is it just the 2 words?
Sorry.
Does the number of wheels also come, like 4, 6, or is it just the 2 words, car and lorry?
In which question?
In B.
In B question, C different.
C, sorry, madam, C.
C intersect D. You're asking whether you're asking C both attributes or one attribute.
Yes, madam.
Difference D. and the lorry. This one car 4 and the lorry 6. Different.
Entire row will appear.
All the
no,
two
entire row,
sorry.
which means the output will consist entire row, vehicle
Yeah.
and wheels column.
Oh, both columns. It consider.
Okay, madam. Thank you, madam.
This is a 2 columns table. This is also two columns table. So output is with 2 columns. Okay. Car 4, then the lorry 6. Car 4, then the lorry 6. Okay.
Okay, madam. Thank you, madam.
Okay. Then the last one. E product F. This one and this one. You need to take the production.
There's going to be 12 row.
Yeah. Then the Parker use. So this is Parker, no? Yeah. Parker USA. Then ink black. Yeah. Let's create it like this. Otherwise, this is the first one, no? Brand. Then the country. Then the type and the color. You can take this one, Parker. Then the USA, you are going to multiply this row by this row, and this row. This is going to multiply with these 3 rows. Okay. The Parker USA, then ink black, Parker USA, then carbon silver, again Parker USA, ink gold. Then how many rows available after this production?
12.
12. This is 4 records. This is 3 records. 4 into 3, 12. So you can write 12 records as the output. Okay. I think it is clear now. This is easy. I'm also giving this kind of question. Then you can acquire marks. You can take marks for this kind of question. Okay. Then there are some queries. You can do some. Let's see. Okay. What, sorry, SQL query. Select vehicle and the base from the table C, where the vehicle name contains the character in second position. You can see this is from the table C. You need to output the vehicle and base from the table C, where the vehicle name contains character A as the second position. So what is the query? Very easy question.
Car and 04, van and 04.
Sorry, you need to provide a SQL query to retrieve the vehicles and the wheels from the table C, where the vehicle name contain A as the second position. Not the output. You need to provide the SQL query. What is the SQL query? To retrieve vehicle and the wheels where the second position of the name consists with A.
Select
vehicle,
vehicle, comma wheel,
comma wheels from which table?
table C,
Table C. What is the condition?
where
Where
name like
name vehicle name. So what is the attributes of this attribute name?
vehicle,
Vehicle like within single quote,
within the double quotation underscore A.
Okay, underscore A. Then only this percentage mark, and only this plus semicolon. You need to insert semicolon at every end of the every SQL command. Okay, so this is the answer. Let's see second one. Okay. Next question. It is also very easy question. You need to select the shoe size from buttons brand from the table A. Shoe size. You need to find the shoe size of buttons. What is the
Select.
select? Yes, select
Shoe size.
shoe size
From table A.
From table A. Where?
Where
Yeah.
brand is equal to buttons.
Is it equal? It's a set of characters. So, okay, you can take.
Is equal to within the quotation or double quotation. You can
take okay. Brand is equal to buttons. Buttons can අකුරු අපි හරියට ලියන්න ඕනේ. BETTANS. Okay. Then let's move into next one. Is it? Yeah, you can take. You can provide the answer. Wait until I clear this one. Okay. What is the answer for that question? You need to select the brands and the character length of the brands from the table E. Table E, brands and the character length of the brands from the table E. How you can find the length of the word? What is the function? It is given. What is the function? How do you can find the length of the given word in SQL? I already discussed. No?
You can use length
function by using a length function. Also, what is the output of this one?
Select brand from table E.
From table E.
Length within the bracket brand.
Within the you need to find the select the brand and the character length of the brand. So you need to output. This is the output. Okay, I'm going to write the output. You need to have the output like this. Wait, it's very difficult to erase in this. Okay, the output is brand Parker length is equal to 1, 2, 3, 4, 5, 6. Okay, then diplomat 1, 2, 3, 4, 5, 6, 7, 8 like this. Then the name like this, another name like this. So to output this one, you can write a query like this. Select brand and the length of brand. Yes, Tirina, your answer is correct. Length, you can provide the brand. This is the field length in the select statement. Okay, from table you need to find the brand and the respective length. So brand, then the length of the brand from table E. Okay, this is the query. Okay, this one okay, this one okay. Then the last one, find the minimum maximum average of the weights from the table C. Here's the table C. Okay, this one.
Select
I'm not
MIN
mean which column?
wheels.
Then hello,
Wheels.
Yeah, you can select MIN wheels. Then the next one,
Again. Max
what is
wheels.
a wheel? Then next one,
comma, AVG,
AVG. What is the
wheels
attribute? Wheels. From which table?
from
From
table C.
table C. So this is the output. Okay. Okay. We already discussed about 3 questions. There is another question to create a ER diagram. You can create a ER diagram for a bank system. Branches, employee, customer accounts are the main entities. You can go through this one and you can draw a ER diagram. This is again normalization. This is the SQL. You need to provide the output for this SQL query. Okay, you can go through this paper. Now it's 4:51. Do you have any questions? Okay, in your exam, you have 5 questions. Out of 5, you need to provide answer for 4 questions. So please go through all the lesson. If you have any doubt, you can contact Hiruni Miss Hiruni. And I only discussed about DBMS part, that means database part. You can go through SQL. There are simple things from SQL. But I think your marks is very low for CAT exam too. Okay, do you have any other questions about exam or if you have any question now, you can raise your question. If not, let's wind up this session. Okay, I think no questions. So thank you and good luck for your final exam.
Thank you, ma'am.
Thank you, madam. Thank you, madam. Thank you, madam.
Excuse me, ma'am.
Okay, go ahead, Tanisha.
Yeah, ma'am. There's a question in the CAT one related to normalization.
Yeah.
Can we have the answer for that question?
Okay, I will upload it into Learn OUSL, okay?
Okay, ma'am. Thank you.